This video is going to go through a problem involving the buoyant force of water. A large rock displaces 2.68 cubic meters of water. Find the buoyant force of the water. First, we need to think about Archimedes' principle, which tells us that any object placed in a fluid apparently loses weight equal to the weight of the displaced fluid. We also need to use the idea that the buoyant force of the water, which is the upward force exerted on the rock, is the same as the weight force of the water that is displaced by the rock. This means that we need to find the weight of water that is displaced by the rock. In order to find the weight force, we need to know the mass of water that is displaced. Writing down everything we know the volume of the rock is 2.68 cubic meters because that is the volume of water it displaces. Since the fluid we are looking at is water, the mass density of water is 1,000 kilograms per cubic meter. We are trying to find the mass and also the weight force of the water. Since we have two different values we are trying to find, we will have two basic equations. First, the mass density d sub m is equal to the mass m divided by volume v. Second, weight force F sub w is equal to mass m multiplied by the acceleration due to gravity g. Rearranging our first equation, we see that mass is equal to mass density multiplied by volume. Our second equation does not change. Weight force is still equal to mass multiplied by g. Now that we have our working equations, we can substitute first to find the mass. Mass is equal to 1,000 kilograms per cubic meter multiplied by 2.68 cubic meters. Multiplying, we see that the mass is equal to 2,680 kilograms. Now that we have the mass, we can find the weight force by multiplying the mass of 2,680 kilograms by the acceleration due to gravity of 9.8 meters per second squared. This gives us a weight force of 26,300 kilogram meters per second squared. The unit of kilogram meters per second squared is the same as Newton, so our weight force of the displaced water, and therefore the buoyant force of the water, is 26,300 newtons. This concludes our buoyant force example.